moderator. He's a professor at Rutgers Business School and assistant director of the Center for Urban Entrepreneurship and Economic Development, Professor Jeffrey Robinson.
All right, good afternoon, everybody. Hope you had a great lunch, quick lunch. We're going to bring on the panel. Do-it-yourself spaces in the Cradel of Innovation. It's do-it-yourself as in hackerspaces. We'll get to that in just a moment. You already heard what I do. I also teach 2 courses at the Rutgers Business School, one in urban entrepreneurship and economic development, and one in social entrepreneurship, innovation, and venture philanthropy. I'm excited to be here today, not only as a professor, but also as an alum of Rutgers College of Engineering. In fact, my first 4 businesses were started in the dorm right on Bush campus. That was my hackerspace for that time. So what we're talking about here today is not something I'm unfamiliar with. It's something that relates to the ideas and innovation, how to create new products, services, and ventures. We kick off this afternoon with a panel discussion about these hackerspaces as the Cradle of Innovation. If you're unfamiliar with hackerspaces, you should know that these are community-operated physical places where people can meet and work on their projects. They are places of collaboration, innovation, and represent the cutting edge of what we're talking about here today, entrepreneurship and innovation. We have an incredible panel assembled here to talk about hackerspaces and the topic of innovation related to them. And so what I hope you'll do is stay tuned with all these pieces of information we'll be telling you. I'll do something that was a little bit different than what was done earlier. I think earlier we told you to turn off your phones and put them on vibrate. I'm actually going to encourage you to turn your phones on. If you tweet or blog or post, let people know what's happening here. I know some of you are already on your computers, and I've already been seeing lots of tweets about what's happening here. So I give you permission to do that. I've also said that, give you a quick overview of how we'll do the panel this afternoon. Each of the panelists, who I'll introduce here in just a moment, will have 1 to 2 minutes to give a little opening statement, tell us a little bit about who they are and what they do, what organizations they represent. And then I have a couple of questions to get the conversation started. And after the conversation gets started, we're going to have you join in with us. So in a few minutes, you'll also see people start to line up for questions from the audience. Our themes for this panel discussion have to do with not only hackerspaces, but what about entrepreneurship? What about innovation for New Jersey? What about the question about how hackerspaces fit into a university setting? Well, we're going to get to all those things here in just a minute. But before we do that, on the screen you can see who's here. You can get an idea of the different folks who are represented here. I'm going to go straight down the lines, starting with Matthew Reimer. He's going to give us a little introduction to himself. We'll go straight down the row, all the way down to Justin from Round Lab. So this is your chance for your 1 minute, 2 minute opening statement.
Thanks a lot. So my name is Matthew Reimer. I'm a co-founder of General Assembly. General Assembly is an educational campus and community for technology, design, and entrepreneurship. We launched in January of this year. We're based in New York City. We're actually going to be, just announced last week that we're going to be opening up a sister campus in London. So that'd be exciting. Prior to General Assembly, I started a social gaming company while I was an undergrad at Yale, and did the whole startup thing, raised venture capital, did not drop out, and built a team. We don't have some people in New York, some people out in California. We're basically building these massively multiplayer team-based games for college campuses, where if you were a student at a particular school, you could face off in this virtual game, kind of like Risk, against your rival school, or your rival fraternity, or your rival dorm. Never really figured out how to make money with that. We got a lot of users, spread pretty virally around the country, but never generated much cash. So eventually the recession hit, we had to shut that down for raising more money. And on the heels of that, moved to New York, and was seeing this real crescendo of startup and tech activity happening more and more. The media was finally starting to pay attention. There was more and more capital flowing, more and more startups were starting. People were leaving traditional industries like finance and fashion and media, and coming into the tech world, and coming into to either join startups or start startups or think about doing things in new ways. And it's really exciting. And I was going to a lot of events and meeting a lot of interesting people. And I thought, well, what if we could create a place and ultimately a community that would sort of be the central hub of a lot of this sort of activity, somewhere where you can come to work, you can come to learn, you can come to socialize, you can come to have serendipitous interactions with people who might be useful to you. And out of those conversations, eventually merge General Assembly. So we're 20,000 square feet campus in New York, which is going to be growing soon, and as I mentioned, London. So more on GA as the panel goes on.
Thank you. Stephen Carter.
Hi, Stephen Carter. I'm the director of a Rutgers unit called RAKE, which is the Continuing and Professional Education Unit for the School of Engineering. We do a lot of professional education in engineering, information technology, and green sciences. I was asked to help assist at Rutgers building a hackerspace network, if you will, and specifically looking at the opportunities of combining educational programs with hackerspaces. There's a lot of synergy between educational programs and hackerspaces, not only at the university level, but right on down into the secondary high school level and on up into the professional education level.
Hey folks, excuse me. I'm Bree Pettis. My background, I was a school teacher for 7 years. I made a lot of videos about how to make things from like hoverboards to secret compartment books. And then I was part of a hackerspace in Seattle back in the day called Hackerbot. And then when I moved to New York, there wasn't a hackerspace. And luckily I ended up connecting with a bunch of hackerspaces in Europe and getting a nice blueprint. If you look up the hackerspace design patterns, there's basic instructions for how anybody can start a hackerspace. And we basically, in New York, set up NYC Resistor, which is one of the first hackerspaces in this new wave of hackerspaces that's hitting the world. And it's an awesome place where anybody can go on a Thursday night and work on projects and get support. Instead of being a group of hackers that are all on our laptops in a closet, in our own closets, we get to come together and be behind our laptops and work together in the same room, and we share a lot of tools and infrastructure. It's been, and out of that, out of the NYC Resistor and the friendship I made, the friendships that were forged there, we started MakerBot Industries, which is a company that is in the Apple I stage of making 3D printers for everybody.
Hi, I'm Rick Anderson from Fair Use Building and Research Labs, FUBAR Labs. We're the first hackerspace in New Jersey. Another one just came up in Wall, and I'm actually hopeful that in the next year or so we'll have a few more here. Because I think that they're a great influence, and they've been definitely one of the things that has allowed me to achieve many more things than I thought possible. And it's often the pattern that Bree and other people have put out there. FUBAR Labs was founded by people in the New Jersey community, alumni of Rutgers, staff of Rutgers. We would have occasional faculty coming in and out of the space. And the idea was that we needed a workshop for tools and things we couldn't afford individually, but as a group we could. And it also allows us to have a space where we can learn together, we can teach, we can invite people in, and be very inclusive. And so we work with high school kids, 8 through 12, but they all come in because they're really interested in the technology. Keep finding out that they're more interested in it. They would like to, dig in, be on an even playing field, and just get a good start. And having a community right there lets you get feedback right away and not have to whittle your ideas away. You can share them.
And Rick, you're in Highland Park.
Oh yeah, exactly. We're in Highland Park, New Jersey, so we're just across the river from here. And we're super excited. I think that the group is good. You can come by on Open Hack Night.
What night is Hack Night?
Open Hack Night is Thursday. And we have Soldering Sunday as well. So we have 2 public periods, and then we have scheduled events outside that. But I mean, people are doing everything from making their own circuit boards, to building their robots, printing 3D objects. So it's just a great space to bring your ideas. And just the one other thing is, as a hackerspace, it can actually be really interesting for disruptive technology. We helped Microchip actually participate in an open source community by having their compilers for the PIC32 be open source and compatible with being able to do Arduino work. And that was a team membership between me and this guy Mark Sproul over at FUBAR, and we just knocked that out of the park. So anyway, we have lots of cool things that were generated, and I want to hand that mic over.
I'm going to interrupt. How many people in here know how to solder? Oh, yes. That's awesome. Okay, For those of you who didn't have your hands up, they can come and see you on Sunday.
Yeah, absolutely. Come by on Sunday. We will take care of that problem.
All right, President Prof.
Hello, I'm Paris Malak. I'm actually on sabbatical from Rowan University, here for a year as a business scholar. My interest is actually in the educational side of it. We do a lot of the design theory work and the design sequence in Rowan. And there's some interesting things about project-based learning and some experiential learning that's very much related to this hackerspace and do-it-yourself concept. There's some very strengths to it, there's some pitfalls to it that actually fall out of the pedagogical literature. It's interesting that you can see some of these things actually play out in some of the small firms that come to Rowan for engineering assistance. You can see sometimes when they've done it right, sometimes when they haven't done it right. And so when you're designing these spaces, it's a good idea to keep in mind what people are learning, how they're learning. And as Mr. Wozniak said earlier, people learn incrementally, and you have to guide that process step by step. And if you don't actually make the leaps, then you can actually sort of clue yourself out of the whole set of possibilities if there's one piece of it that you don't necessarily get. And so hopefully we'll have a chance to get a little bit more into that as we go on later.
And Justin.
Hello. I'm Justin Downs, even though this says I'm Benedetta. She's actually my partner, and together we founded a company called Brown Lab. And what that company does is we are an engineering research and development company. We're located up in Queens, New York. And what we do that's different than a classical research and development company is we focus on an open development structure to solve the real world problems of our clients. And what this entails is using a lot of open source processes, open source tool sets, and also I'd say 99% of people that we are and that we work with are independent contractors or hackers. We're kind of a loose affiliation of people, skilled people that bring our skills together in the space for open development to actually solve these problems. And in the last 2 years, we've been able to utilize this to work with different clients, and 2 examples of what we've done are we made a patient data logging device for UNICEF for operation in Uganda to get patient data entry. We've worked with the Earth Institute up at Columbia University making a solar metering device, which they're implementing in Mali. And we've also worked with conservationists, with private inventors, and even sometimes artists. And so, yeah, I'm happy to be here. Looking forward to hearing what everybody has to say.
All right. Thank you. Let's give the panel a hand. All right. You can see we've got some great people here, so I'm going to target the first question to 3 of them. This one is for Bree, for Matthew, and for Rick. Why are hackerspaces so important? You can take that question as being it's important for entrepreneurs, it's important for the economy, it's important for society, or whichever way you want to take that, but why do you think they're important? Who wants to start?
So hackerspaces are important because they're a place where you can go and find community. So many of the smartest, most cleverest people in our culture are set off to the side and don't have a place where they can be comfortable and get their hack on. Hackerspaces are a great place to be able to get together and experiment. It's a place to do everything wrong as many times as you want, as many times as it takes until it works. It's a place where you can, if you set something on fire, people are gonna applaud rather than judge. So it's a place where it's a place where innovation happens. So entrepreneurship, yada yada yada, blah blah blah, all that stuff is important. Business is important. The future of everything is important. But when you get down to its core, you need a place where innovation can happen, where you can try things and try them again, and then try them again, and then try them again. And hackerspaces offer that place, both as a physical place and a group of peers that can say like, awesome, you totally failed. See if you can fail even dramatically next time.
Sure. So I totally agree with what Bree said. I think the experiential learning piece is really crucial here. There's so much of education that is sort of traditionally taught that is around theory. But oftentimes, time and time again, I will hear people come up to me and talk about how, they always knew about this theory, they knew the theory down pat, but it wasn't until they actually practiced. It wasn't until they actually tried something out themselves, figured out, oh, this works, this doesn't. This is what it feels like to actually get my hands dirty. This is what it feels like to actually practice the craft of technology, of design, of soldering, or any of the things that Wallace was talking about earlier. And I think it's that connecting piece, it's that bringing together of practice with the theory. Oftentimes it will spur forward innovation. I think without the practice, or without having an environment and a community and a nurturing place for that, then everything's just up in the clouds.
Yeah, I mean, again, agree with those. I also think that Hackspace is giving you an ability to get your hands on some things. We have lathes and CNC machines or drill presses, and there's just basically tools. And if you're working on projects, you need to learn your tools. And I think Hackspace is a good place for that, and it helps you learn the process. And instead of being afraid of them, you get a chance to try them. And I think that's a really key element. I think another element that, I guess sort of on the entrepreneurial side, would be that it allows you to bring your idea in, workshop it, tell other people about it, don't hide it. It allows you, so you can kind of like you can whittle that, you can focus that concept before you take it someplace. So that's another element that I think is great with Hackspace.
So let me bring that to the two folks affiliated with universities here. Stephen Carter from Reagan, Professor Von Lockett. So is what you just heard compatible with a university and university?
Very much so. I was involved with helping create the Hackerspace network for the last couple of months. And until just last week, I was very pragmatic. Figure out this revenue stream, figure out this revenue stream, things of that nature. Last week, we brought in 25 undergraduate engineers for a focus group, if you will. And we told them what we're up to. We made it very clear we wanted to hear their ideas. And pretty much across the board, the engineers, mostly undergraduate from a variety of departments, all had the same feelings. They want to have a space to create. They've all had ideas of products that they wish they had the facilities to carry out. They really have a desire to interface with other engineering students outside their core discipline. Electrical engineering, information, mechanical engineering, et cetera, et cetera. And that really brought it home to me. And near the end, we were asking what kind of programs they would like to see. And a couple students raised their hand. And they actually requested a program on how to build an elevator bridge, which surprised me, okay? And again, it really exemplifies that these students are really looking at entrepreneurship and innovation as a career choice.
Did you say an elevator engine?
Elevator bridge.
An elevator bridge.
Giving a sense of your product in under 3 minutes.
In sort of course relating and actually sort of a teaching environment, I think they're an excellent place to have students learn. If you look at the literature, project-based learning, people have just gone on and on about the strengths of it. And Rowan, we've actually sort of incorporated that over the history of Rowan. We started with a $100 million gift, and tasked with being entrepreneurial, has an entrepreneurial bent to it. And so we have this design sequence where we essentially give people access to rapid prototyping, whether it be 3D printers or rapid prototyping circuit boards and whatnot. So our projects sort of do that in a large-scale environment, about 100 students per class. And so they're sort of thrown in there and allowed to build things and whatnot. What we found, and also what the literature says sort of from the pedagogical sense, one of my former colleagues actually coined the phrase, people can become unaffected by their education, meaning that they'll go out and make something, and then if you look at the experiential learning literature, it says you're supposed to go through 4 cycles that start with this concrete experience, go through reflection, and then they're supposed to develop their own understanding of it, and then run some tests in a hackerspace to actually broaden that understanding and make it concrete, and then go back to that concrete learning site and go around in a circle. But if they don't actually learn from what they've built, then they'll just try and make random changes to their design if they don't understand the underlying theory to it. So what we try and focus on is actually getting them to focus on the learning aspect of it, such that when they do those cycles, they make directed improvements. Improvements actually move towards some goal, whether it be product design or some other solution to the problem.
Just back to Stephen Carter for just a moment. What's Rutgers doing in this space? What's the plan?
Ideally, we want to create a network of hackerspaces that not only includes existing labs where we can make use of specialized equipment already in place in those labs, creating new spaces that have the ability to provide tools, workspaces, along with an educational component in those spaces, as well as do outreach and collaborations with external hackerspaces. And we are engaging with our friends at FUBAR Labs to have them as one of the first external hackerspaces in this Rutgers network.
Sounds great. I'm going to go down the table here to Justin. Justin, when you co-founded Ground, it has a different kind of mission than what we've heard thus far from the other folks. Sounds like it has more of a social mission. I teach social entrepreneurship, so I was interested to hear a little bit more about what you're doing, because there may be somebody out here who's thinking about these technology hackerspaces as a vehicle for social change.
Right. Yeah, we started doing what we're doing because through working out, I've been working in fabrication and building in New York for 10, 15 years, and the amazing thing about New York is that you have a whole industrial complex through a cottage industry. You've got X shop that does machining over here, then you've got somebody that does software and so forth. And over time, you build up this network of people that know how to do things, very much like a hackerspace. And I didn't realize, but through my working experience, I became a hacker. New York was a big hackerspace, and New York went through a lot of changing where manufacturing has gotten pushed out and so forth, and there's less space to have this type of learning and have this type of development process. But there's still a whole lot of really smart, skilled people that are unaffiliated with anything. And I think formal hackerspaces like we have here are great, and they do need to be implemented because the kind of natural progression of learning those skills is not there anymore. And so with our business, we were trying to take these people and these unaffiliated skill sets and coordinate their efforts to actually solve real problems. Because even though they're hackerspaces, and you might see a hackerspace and somebody makes a skateboard or a jet powered something or other, the skill sets that are in these hackerspaces are very real skill sets that can be applied. And the people that are in hackerspaces are very smart and very innovative people, and they are solving problems. And so the big shift, or what's kind of hard, is how do you actually apply those skills to a problem set and deal with that contract and deal with those IP rights and deal with the funding of it, because there's a huge potential in terms of the clients that need solutions and don't necessarily care about that IP cycle of making money. They want that solution. And then there's a whole lot of people that want to build solutions and can't do it. And so how do you bring the two together? And that's what we're trying to do. It's a process.
All right. I'm going to have one more question for the panel, but if you have questions, now's your chance to head towards one of the microphones. We have them here in the front, one here, and there's one over here. You can form a line behind the microphone. We'll be calling on you in just a minute. The last question I have for the panel, I'm going to direct to Bree. Tell us some more about MakerBot. I was reading a New York Times article about you and about what was happening at NYC Resistor, and it just boggled my mind. I've seen 3D printing, and to hear what you've done with it, this sounds phenomenal. So tell us some more about it and how you see that fitting into the problem.
Sure. So when we started NYC Resistor, I wanted NYC Resistor to exist. We got the domain name, we set up a Google group, we set up an IRC channel. We're nerds. If there's one thing that we can do, we can set up infrastructure. So we set up the infrastructure first before we had anybody involved. And then I set up a honeypot. Honeypot is something that you might put out to attract bears. But instead of attracting bears, I wanted to attract people who actually do things. Because it turns out there's a lot of people in the world who are willing to talk a lot, and there's not as many people who are willing to get their hands dirty and get stuff done. And I wanted to get those people involved. So I set up something called the Microcontroller Study Group. And this was a group that was, anybody could come. It happened once a month. And the idea was, come, bring your projects, show and tell, and then afterwards we go out for a bite to eat and drink. And that's a critical part, actually. One of the first people who came to one of these meetings was a guy named Zach. And by the way that I interact with people, I'd say, hi, my name is Bree. What do you make? And he said, well, I make self-replicating robots. And my immediate response was, well, how can I help? And so for a couple of years as a hobby, we were working on 3D printers because we wanted one. 3D printer is a machine, we call them replicators. It is a machine that can make you anything you want. You have an idea, you make a 3D design on a computer, you press print, and it builds it up layer by layer of plastic, and you have a real physical thing. As a maker, it was a holy grail for us to make something that makes things. So we worked on this and set a bunch of stuff on fire, and finally we had one that almost worked. Like it worked for like 5 minutes, enough to make a small shot glass, which was leaky, but it doesn't matter. If you drink fast enough, that kind of stuff doesn't matter. And at that point we were like, we got something. Because at that point, 3D printers cost between $100,000 and $1.5 million. And we put in about $600 or $700 many times, getting as many, trying to build something with as many off-the-shelf components. And we had a laser cutter. As a community at NYC Resistor, by that point we'd been at NYC Resistor going for about a year, and we'd each chip in $1,000 so we could afford a $20,000 laser cutter, which is a laser cutter is something that everyone should have. It's a big freaking laser that you can put something into the bay and it cuts it. How fun is that? You get to say, fire the laser. You press the big red button and sure enough, it fires up and cuts things out of acrylic or wood or whatever. So I'll try and, I realize I'm running this a little bit long, I'll try and cut to the chase here. But basically what happened was we got to the point where it worked and we were like, this is great, now we have a machine that can make us anything. And we were like, let's make it so everyone can have one of these. And at NYC Resistor we have our motto is we learn, share, and make things. So we figured it out and we shared it. We're open source. You can actually download all the plans and make it yourself if you want to. It'll take you a lot longer and cost you more than if you buy the kit from us. And now we made a kit so that everybody could, so that a community of people could all have the same machine, which are a little fussy sometimes. But because there's 6,000 of them in the world now, if you have a problem, it's very likely there's somebody in your town, or you can get somebody on chat, or you can get somebody, or you can just call support and you'll get help. So now there's a community of 6,000 people who have MakerBots 3D printers in the world that I think we have something like a third market share in the world of 3D printers, something like this. But we started that because we were in a hackerspace where we had the tools and friendship. I think friendship, besides drinking, I think friendship is another core component of innovation and not to be underestimated. So if there's anything, I see there's all the suits up front here, but I think the students are all up in the grandstands. If there's anything you can do here at school to make it worth your money, it's probably make friends who are ideally smarter than you or as smart as you, but in different ways. So a hackerspace is another place to find people who are interesting, hopefully like you.
All right. Time for some more conversation with you. Who has questions for our panel, any of our panelists? Don't all move at once. All right, come on up to the microphone. Come on this side. Way on this side. All right. Introduce yourself and fire away.
Hi, my name is Alex. I'm wondering, in these hacker spaces, is there any intellectual property theft, or how do you deal with people stealing with other people's ideas?
Well, I'll address it from the university point of view. We've had some initial discussions with the university council, and I can say that Rutgers is trying to do everything possible to alleviate IP issues as far as the hackerspace and its membership in the university goes. And now I'm going to turn the microphone over to discuss how people within the hackerspace deal with IP.
Intellectual property is over. It is. I mean, people who are still involved, give it up.
I'd also say, just from creating a community that you can share ideas with and trust is actually important. And when you grow a group organically, it's actually a lot easier to maintain And our goal at Full Bar Labs is really to have the community there, and anybody's idea can be floated around, but it's still your idea. So we're not trying to make people not have their idea, but the concept is that you get it out there so that you get the feedback you need to know, is this going to fly or not? So we're very open to that. We really push for open source because that makes it the easiest, because we're oftentimes building on open source items. And I think that's the key thing, is because we're building off of that open intellectual property. You know, we have to respect and give back a little bit into that, but it also makes a very interesting product.
And also, I found working with individuals, and we bring a whole lot of different people with a whole lot of different skill sets that put together a code base and then we give it to a client. And 9 times out of 10, the clients are for open source because they want the solution, they don't want IP right. And the people we work with are okay open sourcing their code and their work because A, they get credit for it, and B, they did it. So they do it much better than anybody else. So somebody else could take their work and try to use it in a different way, but the person that originally did it always gets a better price point because they're much better at doing it. And so it's just a different emphasis, it's getting paid for your labor instead of getting paid for your legal rights. And I find it to be very effective. And yeah, I think IP rights I'm the way out in a lot of ways.
I think ultimately 99% of your success is going to be determined by execution. Ideas are a dime a dozen. They're not protectable in any way. Whatever idea you have has probably been thought of by 100 people already. If you find yourself in a position where you are too afraid to talk about your idea, probably needs honing, is probably wrong. It probably needs several steps of evolution before it's like a really good idea. If you're too afraid to share that with anyone, because you think that by sharing it, everything you have will go away, that someone will just copy your idea and just beat you to punch, it's probably not that good of an idea in the first place. And I think time and time again, the most successful entrepreneurs will say, the most successful people who build stuff and create companies or products or technologies will really encourage you to share your idea, get feedback on it, talk to as many people as you can, especially potential customers, potential users, potential early adopters, because ultimately it's probably going to change, it's probably going to evolve, and without keeping it locked away in a safe in your closet, it's just going to sit there and go still. So get it out there, talk to people. Thank you.
Thank you.
Let's go over here.
What do you think about Creative Commons kind of licensing, where it's like you can share it and you have the right to have it, but people can take it, modify it, and send it back?
Love it. I actually have a whole site called Thingiverse where people share their designs.
And
it
one
works.
other thing is, what do you think about companies now, how they're getting kind of crazy about hacking hardware, things like that, where they just take and like sue people who make things better for themselves or for other people and say, I can take this and I can make it do better things than it was originally intended because of X, Y, Z reasons.
Probably the best example of that is the Kinect that came out recently. Kinect is a little thing you connect to your Xbox that allows you to play different kinds of games. And it turns out it also works as a 3D scanner and it's really cheap. Microsoft put it out there and didn't let people have access to the guts. And then, too bad for them. Everybody wanted it, so they, everybody just hacked around it, figured out how to use it, and then finally, Microsoft liked it and said, okay, we'll make an SDK.
I was wondering, how would a company recover, like, knowing like Sony's history or something like that, where with the PS3, like, is there any way that a company could recover and say, all right, I'm sorry, and then...
That would be a good start.
Well, I think too, there's one thing is that a lot of devices, there isn't that limitation. It's your device, you're going to attack it. So a lot of the stuff that happened with the Kinect is actually fully within the capabilities of the device, and what was the protected IP wasn't actually gotten to. So it actually works great as the device itself, but the part that anyone was afraid of, the IP piece, that actually wasn't necessary for its operation, so people had a great time anyway. So there's no rule saying you can't use many of these devices and improve upon them. There's complications about how the company enforces the rule, and trademarks, etc.
All right, thank you. Got one question here, and one question here. We probably going to wrap it up after that, so. Okay.
Fine. I would like to know someone who is not very familiar with the hackerspace space. What is it you have to bring to this space? What do you have to put on the table? And how will you get to participate into that? Well, that's one. And the second one, which I guess it will be easy for you to answer, is how would you make it? I mean, how would you found it, right? So because you need to pay for things you have there in the long run.
Okay, so the first question was about founding Hackerspace, sorry. But basically, you need to get your friends together. I mean, that's the raw ingredient. It's the people that you talk to about doing stuff. You certainly can't say, hey, we get together on a regular basis, let's do this. And if you look at the story of Fubar Labs, it was a group of ex-students, it was a group of people in the community, comic book store owner, and they met in basements, they met in a comic book store for several months. And we met in diners. We got, after a while, we would reserve a room and have the 8 or 9, 10 people that started coalescing together. And then from there, it was like, wow, this is happening. This is something that we could really do. And in fact, it took one member at the time to go, let's just put this down in a spreadsheet. And we went, oh, well, we have this budget, and if we start forming ourselves as a group, we can do membership dues, etc. And suddenly, we had the right amount of money to get a basic space, and we pulled it off. And I think that can just can happen again and again. And there's a lot of good templates to follow. So the hackerspaces.org is a good central resource. It's there. It's possible. You can start with a few people and build it up. So I could see New Jersey having 3 to 5 easily.
And then within the university, ideally, a monthly membership model would probably be not ideal. But we're working on combining Hackerspace membership with some short courses where we take a 1-week course in Arduino automation control. That would include 12 months of Hackerspace membership. We're also, hopefully reach out to some corporations, donations welcome, in order to help fund these hackerspaces. And of course, within the university itself, although we're a little financially challenged.
Right here.
Hi, my name is Alex. Sure, there are a lot of hacker spaces that focus on electronics and computer programming. I was wondering if there are any that are more focused in other fields, such as chemistry, biology, because I feel these are fields that kind of disappeared when we stopped making all those unsafe chemistry sets for kids and stuff.
Just down the street from NYC is the Gen Space, which is a biohacking lab. And they actually met, and they asked NYC if they could meet on Wednesday nights, and they did until they had enough members that they could go off and get their own lab. And they set up in a former bank building, and they have a corner of it that's actually like a clean room, and they're doing really cool stuff. They're doing projects to develop USB webcam microscopes for schools right now, doing really interesting stuff around biology. So yeah, they're out there.
And hackerspaces are now defined two sides. There are hackerspaces for business, and people get together and build business plans instead of building robots. There are hackerspaces for the arts, with spaces with pianos, electric guitars, and things of that nature. So hackerspaces span everything.
I'll just add two things about that. Is that it's a good incentive to make more friends, so you can then found another hackerspace or get people to combine, because you can invite people from different groups over. And I think this is something that Rutgers could really tap, is that student groups and students are already doing things on their own. And being able to give them some space to bring their group to is a big deal. And the other part is thinking of it as an association of potential hackerspaces is bring those resources from the disparate parts of the university that can actually be used by students and get it to students. So anyway.